What if I told you that the very act of falling asleep, our ultimate form of rest and recovery, could actually be the most dangerous time of day for some people's brains? It's a pretty wild thought, right? Today, we're going to dive deep into this fascinating and honestly pretty complex relationship between our nightly rhythms and our brain's electrical stability. For most of us, sleep is about feeling refreshed, about optimizing our day. But as this quote highlights, for millions of people, it's so much more. It's a critical biological safeguard, a nightly negotiation with their own brain chemistry. Welcome to Sleepedia, a corner of the internet totally dedicated to the science of sleep and circadian rhythms. We're going to break down a connection that science is really just starting to get its head around. We think of sleep as this quiet shutdown, but the reality is it's anything but. It's an incredibly active time for the brain, and for some, that activity makes it far more volatile. This is the whole paradox. How can a state that's designed for healing sometimes trigger an electrical storm in the brain? To really get this, we have to completely throw out that old idea of the brain as a computer that just powers down for the night. Instead, I want you to imagine it as this huge, incredibly complex orchestra. During the day, it's a little bit all over the place, kind of chaotic, but at night, something truly magical happens. So how does this beautiful nocturnal symphony suddenly turn dangerous? Well, it all comes down to the difference in how the brain's musicians, the neurons, play together when we're awake versus when we're deeply asleep. During the day, your brain is what we call dysynchronized. It's like that messy orchestra, right? You've got different sections all playing different tunes at the same time. You're thinking, you're moving, you're talking. But when you enter that deep, non-rapid eye movement sleep, or NREM sleep, the orchestra starts to play in perfect, beautiful unison. This is called synchrony. Now this synchrony, it's not a mistake. It's actually a masterpiece of our biology. These slow, rhythmic waves are absolutely crucial for things like moving memories from your short-term inbox to your long-term storage. For a healthy brain, this is a beautiful and totally necessary process. But what if some of the musicians in that orchestra are, let's say, irritable, prone to hitting a wrong note every now and then? Well, in the chaos of the daytime, that one wrong note just gets lost in the noise. But during the synchronized symphony of sleep, that single spark, it gets amplified. It's like the synchrony acts as a megaphone, turning a tiny whisper into a massive shout that spreads everywhere. So let's get even more specific. Deep in your brain, you've got a structure called the thalamus. Think of it as the brain's switchboard operator. At night, it tries to block out noise from the outside world by producing these little bursts of activity called sleep spindles. They're meant to be protective. But in brains that are prone to seizures, these protective signals can get hijacked. The operator, who's just trying to close the door quietly, accidentally hits the emergency broadcast button, and suddenly that protective signal becomes the trigger. But it's not just about these big, obvious seizures that we see. Sometimes the danger is way more subtle. Your rest can be stolen in ways you can't even see, leaving you feeling just exhausted and confused without really knowing why. And it turns out, for keeping your brain stable, the consistency of your internal clock, your circadian rhythm, is maybe even more important than the total number of hours you sleep. Believe it or not, every single cell in your brain has these little clock genes that regulate how sensitive it is. And this chart illustrates the problem perfectly. When we do that thing called social jet lag, staying up super late and sleeping in on the weekends, we are constantly forcing those clock genes to reprogram themselves. For a sensitive brain, this is like lowering the wall of a dam right before a big storm. It dramatically lowers the seizure threshold, especially during that really vulnerable time around dawn when you're transitioning out of sleep. So this brings us to a question that so many people with epilepsy ask. They might sleep for 8, 9, maybe even 10 hours, but they wake up feeling like they haven't slept a wink. What is going on? Well, the answer lies with a hidden thief. And the culprit has a name. They're called Interictal Epileptiform Discharges, or IEDs for short. The best way to think of them is as these tiny mini sparks that just flicker in the brain between the major seizures. And guess what? They absolutely love to come out at night.
You could have dozens, even hundreds of these IEDs a night and be totally unaware. But here's the real problem. They constantly disrupt the brain's nightly cleaning crew, which is called the glymphatic system. This system only works when you're in deep sleep. So every time one of these mini sparks goes off, the cleaning crew has to stop what it's doing. If this happens all night long, the cleaning never really gets done, and you wake up with a buildup of all this metabolic trash that causes that awful next-day brain fog.
This all leads to another huge challenge. Seizures that don't look anything like what we think of as seizures. And this creates a massive diagnostic puzzle that can leave people suffering for years and years without getting the right answers. I mean, this is such a huge source of misdiagnosis. Your frontal lobe is what controls your behavior, so seizures that start there can look exactly like night terrors or sleepwalking or just thrashing around in a bad dream. People can be told for years that they're just having bad dreams, when in reality, they're experiencing clusters of actual nocturnal seizures. And you can see how this traps people in a truly vicious cycle. The seizures prevent them from getting deep, restorative sleep, but that very lack of quality sleep makes their brain even more likely to have seizures the next night. It's this horrible feedback loop that can feel absolutely impossible to break.
But, and this is a big but, there's a lot of hope. The future of treatment isn't just about stopping the storm anymore, it's about teaching the brain to find its healthy rhythm again. The approach is getting so much smarter, way more elegant, and much more in tune with our natural biology.
We're really seeing a fundamental shift in philosophy here. For a long time, the goal was just to suppress all brain activity with these really powerful medications. The new approach, though, is about guiding the brain back to its natural, healthy rhythms. It's about working with the brain, not just fighting against it. One of the most exciting new strategies is something called chronotherapy. It's so logical when you think about it. If we know a person's seizures are most likely to happen during that deep NREM sleep, why not just time their medication to be at its most powerful during exactly those hours? This is just smarter medicine. You maximize the protection at night while minimizing the side effects during the day. And then there's this, vagus nerve stimulation, or VNS. This technology is just incredible. It basically acts like a pacemaker for the mind. It was originally designed just to stop seizures, but then researchers discovered it has this amazing side effect. It actually helps tune the brain's entire sleep architecture. It smooths out those dangerous transitions between sleep stages and reduces that risky hypersynchrony that can trigger an event. When you really boil it down, the goal of all this research and all these new treatments is pretty profound. It's about transforming the night from a time of fear and vulnerability into a period of genuine safety and neurological healing. It's about finally letting the brain do the incredible restorative work it was designed for. So as we wrap this up, I want to leave you with this one big thought. For so long, we thought the answer was just to silence the noise in the brain, to just shut everything down. But what if true healing isn't about forcing silence at all? What if it's about helping the brain's incredible orchestra find its perfect, harmonious rhythm once again?